In this short video, we'll look at block diagram reduction using Mason's rules. And using Mason's rule, the transfer function is given by sum of mi times delta I divided by delta, where mi is the gain of the ith forward path. Delta is 1 minus sum of loop gains plus sum of product of two non-touching loops minus sum of product of three non-touching loops, and so on and so forth. So 4 non-touching loops and 5 non-touching loops, everything. Delta I is delta minus terms associated with loops that touch forward path mi. So let's look at an example here. So the first thing we do here is look at the forward paths. In this case, there are two forward paths, M1 and M2. Those are the gains for the forward paths. So all you do is just multiply the transfer functions here. So as you go forward, this is 3 times G2, and as you go forward here, it is G1 times G2. The next thing you do is find the loops. There's 2 loops, L1 and L2, as shown. Once again, as you go forward along the signal direction here, like so, you multiply the transfer function. This is G2 times 0.5, and as you enter this summation junction, there is a negative sign here. That's why you get minus G2 times 0.5. Same thing with the L2. Now we write down what delta is. Delta is 1 minus L1 plus L2 plus 0, because there are no 2 loops that do not touch each other. So rest of the terms are all 0. So we put in the terms. So you get delta is 1 plus 0.5 G2 plus G1 G2. Delta is 1 is delta minus terms associated with the forward path M1, associated with loops that touch forward path M1. Now that will give us that, and these two cancel because both this is associated with loop 2, this is associated with this is associated with loop 1, this is associated with loop 2, and L1 and L2 touch M1, so you need to knock off both terms. So and delta 1 ends up being 1. Similarly for delta 2 is delta minus terms associated with loops that touch M2. Once again, you'll see that both loops L1 and L2 touch forward path M1. Therefore, both terms drop out. Now finally, we write our transfer function like so. So that gives you the final transfer function right here. Now, we can go back and look at what do you mean by loops touching forward path 1. If you look at M1, this is your forward path M1, and you look at loop 2 right here, that shares these edges with M1, therefore L1 touches M1. And look at L2 right here, this guy once again shares edges right here with M1. So L1 and L2 touch M1. That's the end of our lecture here.